How to determine that polygons are similar without, well, maybe there are some graphs on here. Nope, without graphs. So let's get started first by talking about the scale factor again. So remember, I had a few of these questions this morning when kids were coming in. You look at the two P's there. This one is going to this one because of the little prime here. When you have the prime, that's the one it goes to. So P is going to P prime. So is this getting bigger or smaller? Is this a reduction or an enlargement? Okay, so if it's a reduction, Jill, what is my scale factors ratio? If it's a reduction, it needs to get smaller. So what number needs to be on top?
The smaller?
Yep.
So it's 18 over.
And 3 goes into both of those. Oh, bigger number. 6 goes into both of those. So that is 3 over 5. So K equals 3/5. So again, we're looking for the primes. So the blue is going to the red. So Abby, is that a reduction or an enlargement? So I have some horizontal sides. So I can count the number of squares that they have, some horizontal and vertical sides there. So if I were to do my ratio for this one, Harmony, what would it be if it's going to be an enlargement? 4 over 2, which is just 2. So your scale factor for this one is 2. All right, so how do we know if polygons are similar? So we're going to be talking about all the similarity things that we can do with triangles, but for polygons, you need to make sure all the corresponding angles are congruent. So for a polygon to be similar, one of the ways is that the corresponding angles are all congruent. And the corresponding sides are also proportional, meaning that if you were to simplify all of the proportions, they would simplify to the same thing. And we've kind of been looking at that a little bit because I did a few of those things with you guys yesterday, plus a little bit this morning without actually saying what we were doing. So if you're looking at these two figures here, let's start with the similarity statement. You'll notice this little squiggly line. It kind of looks like the congruent symbol without the equals, right? So this little squiggly line means similar. So if you have a squiggly line in between the two, it's saying that polygon ADCB is similar to the polygon next to it. What polygon is it similar to? It's not the same size, they're just similar to each other. So Carmichael, what is ADCB similar to? Yeah, E and A both have single angle markings, so they line up. D has 4 and H has 4, so that is why those line up. C has 3 and G has 3. And B has 2 and F has 2. So that's why those are lined up the way they are. So we're not saying they are congruent. We are saying that they are similar. Make sure you draw your arrow to the squiggly. So one of the things it says is that all the angles are congruent. So the corresponding angles are congruent. So angle A, Morgan, is congruent to angle E. And Logan, angle D is congruent to angle. And Katie, angle G is congruent to angle. Angle G is congruent to angle. Good. And Casey, angle F is congruent to angle. Good. So one of the things it tells you is that the corresponding angles must be congruent for the polygon to be similar. So this has that piece done. The next thing that needs to happen is that the corresponding sides need to be in proportion with each other. So this is saying that AD corresponds with EH. You can see that up here too. Do you guys see that? And we'll look at the numbers in a second here. So what does DC, Cameron, correspond to? Good. And Greg, do you have a question? Do you want to answer the next one?
Next one.
BC is corresponding with what?
FG.
FG, good. And Ian, what is FE corresponding with?
BA.
So you'll notice the bigger polygons are all on top. It doesn't really matter which one's on top or which one's on bottom. Just don't mix and match. And the smallers are all on bottom. The point is that if you start with one of the polygons, like if you start with your first polygon in the numerator, all of its pieces need to be in the numerator, okay? If you start with the smaller pieces all in the numerator, they all need to stay in the numerator. Don't start flipping it around, okay? But if we look at these numbers now, we can see that they're in proportion to each other. So AD over EH, DC over HG, BC over FG, and then BA over EF. What do those all simplify to? Do they all simplify to the same thing? Yeah, they all simplify to 2. So it's important that they all simplify to the same thing. If they all simplify to the same thing, you have a similar polygon. So that is the definition of a similar polygon. As a reminder, you have a quiz on Friday. The quiz will include vocabulary as well as your test that will be coming up next week sometime. Probably on Friday of next week. Okay, so let's practice. In the diagram, triangle ABC is similar to triangle JKL. So Daniel, help me with the angles there.
ABC's.
Angle A is congruent to what?
J.
Good. Angle B is congruent to angle?
K.
Good.
And C.
Make sure you draw that congruent symbol for angle B. It was not there for whatever reason, so make sure you're not just writing angle K there because it should say that it's congruent. Okay, let's look at the sides that are corresponding then. So it says that AC is corresponding to JL. Emma, what is BC corresponding to? BC right here. Which one is it corresponding to? KL, because they're both the last two pieces. And Hiku, what is KJ corresponding to? Okay, so we have our corresponding sides. I don't know why it's asking for the similarity statement when we already have it up there. So just to check that, AC is 21 and JL is 28. BC is 36 and KL is 48. BA is 27 and KJ is 36. So 7 goes into each of those, so that's 3 over 4. 12 goes into both of those. That's 3 over 4. And 9 goes into both of those. So that's 3 over 4. So do you see that they're similar based on that? They all simplify to 3/4. So your scale factor is depending on which way it's going. So your scale factor, if it was going this way, it's getting larger, would be 4 over 3, right? As an enlargement. Or it could be 3 over 4, depending on the direction. So it doesn't matter which way you write that. So again, you already have the similarity statement. We have it up there as JKL. Questions there? Greg, you better not make Hayden mad today. She has a candy cane. All right, so determine if the polygons are similar and justify your reasoning. So the first thing you should check if you're given angles is that the corresponding angles are congruent. So if we look at these angles, do we have angles that are all congruent here? Do we have that? So first thing, corresponding angles are congruent. So that's good. So now we're going to check that the proportions of our sides are all the same. So what would 11 go over? 11 over what, Logan? So we do 11 over 110. Hunter. If we're going with 15, 15 would be over. Gabe. 4 would go over. And Austin. 8 would go over. So you'll notice my first polygon all has pieces on top, and my second polygon all has pieces in the denominator. So it's important that you're putting the same polygon in the numerator and the same polygon in the denominator. So if we look at this, do they all simplify to be the same ratio? Are the sides proportional? Are they all the same ratio? So we can say check, the sides are proportional. So that means that they are similar. So what is the similarity statement you would write, Abby, since they are similar?
A, B, C is congruent to W, X, Y, Z.
Are they congruent?
Similar.
Similar. I know.
Hi, I hear you.
Okay, stop. You're snoring. All right. So the next one, number 2. The first thing you check is the angles. So are our corresponding angles congruent? Olivia, are our corresponding angles congruent? So 36.9 has a match on the other one? No, it does not. So 36.9 is not the same as that. 53.1 is not the same as 52.1. So corresponding angles are not congruent, so therefore it is not similar.
You have to have both of those to be able to be.
Yes.
Okay.
So once you can see that, you can say no. Although, if you know one, the other one is going to probably be true because it forces it to be based on, like, math reasoning. That I'm not going to get into with you guys. There's like proofs out there and stuff. All right.
We have a lot of notes.
Again, I feel like this is a marathon of notes because we're trying to get this unit in before the end of the semester. All right, determine if the polygons are similar and justify your reasoning. So, are corresponding angles congruent? Are the corresponding angles congruent? Yes, they are all 90 degrees. Every angle in that is 90 degrees. So, corresponding angles but the problem here is we really don't know which angle corresponds to which angle because they're all 90 degrees, right? So when we set up our proportion, we need to set up a short side with a short side and a long side with a long side. So like when you go to do your proportion, make sure you do a short side of one of the polygons over short side of the other polygon. equal to a long side of the first polygon over a long side of the other polygon. Why do we only have to do two sides in this case? I could set up all four, but do I need to set up all four? Helena, why wouldn't I need to set up all four ratios here? Doesn't have to do with that. What shape is this? It's a rectangle. And what do we know about opposite sides of a rectangle? They're equal. So wouldn't that just be the exact same ratio as another one that we already have there? So if you want to, you can set up all four, but it would just be writing the same thing again. So that's why you don't have to worry about that. So I'm going to say my short side of this one is 18. What is my short side of the other one there? Jill, what's my short side of this one? Good. My short side of, yeah, my long side of the other one is 30, or my first one is 32. What is it over the other one?
26.
Yes. So this may not be in proportion. Both have to be true. So we'll see what goes into both 18 and 12. 3, right? 6, bigger. Okay. 3 over 2. And then 2 goes into both of those, so that's 16 over 13. Are those equal to each other? No, so we have the same angles, but not the same, but they're not in proportion. So therefore it is not similar. So yes, you do need both to be able to prove that it is similar. Okay, the next one, are corresponding angles congruent? Are they marked congruent? Yeah. All right, so we do have to line this up right in order to do this. So I'm going to start with 6. What has to be in the denominator of the 6? Hunter, what needs to be in the denominator of the 6? 9, because that's the corresponding side. It's between the 1 and the 3 marked angle. Casey, what would have to be in the denominator of 4?
6.
Because it's between the 1 and the 2 marked angle. And then 8 would be over what? Well, Morgan, I just said the answer. Morgan. 12. Thank you. So that is 1 over 3. 2 over 3. Did I do something wrong there? Yes, I did. That's not 1 over 3. That's 2 over 3. Okay, so is 2 over 3 equal to 2 over 3 equal to 2 over 3? Yes. So they are proportional, which means we have similar polygons here. So what is my similarity statement here? Oh, there's no letters. Never mind. They are similar. All right. Questions on that one before we do another one? These notes ever end.
Oh my god. It's taking forever.
We're not going to have time.
I'm going to skip. No, we don't have to skip this one. We have to do it. All right. So find the scale factor and the value of each variable given triangle EDF is similar to GIH. So what do you know about two similar triangles and their angles? They are, what do you know about the angles of a similar polygon? Angles are corresponding, but what about the corresponding angles do we know? Carmichael? They're congruent. So E is corresponding with G. So if E is 108 here, what is G? 108, because the corresponding angles are congruent. So if this is 108, so is that one. So I is corresponding with D, and H is corresponding with F. Okay, so can we find the letter that's missing there, the letter Z? How could we find Z? What do triangles' angles add to? So we do Z plus 108 plus 26 equals 180. So Z is 46 degrees. So which corresponding side both have numbers on them? Which corresponding sides both have numbers on them? But let's just set it up in general. So 7 would be over what? What would 7 be over? 7 is ED, which corresponds to what? ED is corresponding to GI, so it would be 7 over X is proportional to EF, which is corresponding to HG, so that would be over 14, which is corresponding to DF over IH, which is 12 over 21. So we'll notice that you have two variables in here, right? Do you guys see that? But you do have one that does not have variables in it. Do you guys see that? So what you're going to do is you're going to split this into two now that you know which one doesn't. So you have 7 over X equals 12 over 21, and Y over 14 equals 12 over 21. That way you can actually find the variables, because we talked about cross multiplication last week. What is 147 divided by 12? 12.25. And then we'll do the other one, which is 21y. 12 times 14 is?
No, I can't do math. Okay. 160.
168, you said?
Yeah.
And then divide that by 21.
8.
8? Okay, so you found all your missing pieces. So look at that and see what questions you have for me on that one. All right. Okay, so it says find the value of each variable if triangle JLM is similar to QST. So we know that JL over QS is proportional to LM over ST, which is proportional to JM over QT. How did I find those? What did I do to find that? Somebody know how I found those? What'd you say, Harmony? Yeah, I just said, okay, these two line up in the similarity statement, these two line up in the similarity statement, and these two line up in the similarity statement. I did that so it's easier when I go to write out all of the numbers that are in this. So now I know that I can replace JL with 3y minus 2, and QS is 5. Since they're similar, we can do this. LM is 6x minus 3. And ST is 3. JM is 4. And QT is 2. Okay, so you'll notice we have two variables again, so we're going to have to split two equations again. Which one are we going to have to use in both of them, though? Which one of those ratios are you going to have to use in both of them? 4 over 2, because it has two numbers in it. It doesn't have a variable in it. So we have 4 over 2. Equals 6x minus 3 times over 3, sorry. And then I'm going to do it up here instead so that there's space. 4 over 2 equals 3y minus 2 over 5. Whenever it's separated by addition or subtraction in the numerator, remember you need to use parentheses around it so that you don't forget to distribute. So I have 12x minus 6 equals 12. So I have 12x equals 18. I forgot the x. Divide by 12. Is that 1.5? Is 18 divided by 12 1.5? Okay. So again, make sure there's parentheses and cross multiply the next one. Some of you guys skip steps, like you don't write that very first step that I wrote up there, the 2 times the quantity, 6x minus 3. You just distribute in your head and multiply. Completely fine. I'm just doing that so you know what's going on if you have no clue where these numbers are coming from. So that's 4 times 5 equals 2 times the quantity 3y minus 2. So y equals 4. All right. What questions do you have there? I think we'll be able to get one more example in, and then I'll be throwing your homework at you as you walk out the door again. Because why not, right? Go to the very last one for me. The very last problem. So in the diagram, QSP, which is this big triangle, is similar to RST, which is the little triangle. Find the scale factor and the values of the variables. So first of all, what is the total length of QS? What is the total length of QS? Daniel, what is the total length of QS?
12.
And what is the total length of PS? What? Plus what? It's not just 15, because this is 15. So it's 15 plus x. So you need to know that. So if we are looking at this, we have QS over RS, SP over ST, and QP over RT. So that's 12 over 3, 15 plus x over x, and 12 over y. So our scale factor is 12 over 3, which is just 4. Do you guys see that? If you do 12 divided by 3, that's 4. So that's our scale factor. We can figure that out there. And then we're just going to separate our equations here. So I have 12 over 3 equals 15 plus x over x. And 12 over 3 equals 12 over y. And then you'll cross multiply. And I will cross multiply again. All right, and we got our scale factor up here. So go ahead and finish that up.